Okay students, this we are continuing. See, there is an inclined plane theta, there is a pulley, there is another block of capital M, there is a rope, the rope is pulled with the force F. Okay, now what is the acceleration? Acceleration is okay, acceleration, okay, minimum force, how much? If of applied force is greater than minimum force, then what is the acceleration? So in this case, if you draw a free body diagram, so this question can be directly answered. What is a, so there is no other block in this direction. The rope is pulled with the force F. What is the tension in the rope? Tension is equal to force, because what the force, whatever force is here, should be same throughout the rope. Rope doesn't have any acceleration. If we want to prove this, say take massless rope, we are applying force. Let's assume the tension T. Mass F is equal to m into A. The rope has no mass. M is equal to 0. F minus T must be equal to m is 0 and it is equal to 0. F becomes T. So which is nothing but force. What if the rope is pulled with some force? The tension in the rope becomes F. So if you draw the free body diagram, this is F. As of now, I'll take it as T, and it is capital mg sin theta. So T must be greater than or equal to mg sin theta to move the block. If it is T greater than mg sin theta, if there is a friction included, the friction is included, we should see in which direction the body is trying to go. Then we should find. Okay, next, second question. There is a person in a cage. He is standing in a cage. The rope is tied. Mass of the cage is mc. Mass of the man is ml. And wait a minute. It is connected to a pulley, and the pulley is passing through the hands of the man. This fellow is trying to pull upwards, and they are moving with acceleration A in the upward direction. Find, the question here is normal reaction between man and cage. What is the normal reaction? There is one more question. Tension in the rope. Tension in the rope. Now, to solve this kind of problems, let's take this as another example. So to solve this kind of problems, let's assume the man as one block, cap mass of man. What are the forces acting on the man? See, there is a tension in the rope. The tension is acting in the upward direction. He is going upwards. See carefully, he is in contact with the cage. Because he is contact with the cage will exert some upward normal from the bottom. So one force in the upward direction is T, another force is normal from the cage. I can just take it as N. And there is one more force, that is the onward force, mass of man into G. They are going with the upward direction. It is easy. Newton's laws of motion problems are very easy, as if you understand. N plus T is equal to N plus T minus mass of man into G is equal to mass of man into A. This is one expression. Let's go to the cage. I am considering cage also as one of the block. How many forces are attached to the cage? It is the cage. This is one force, upward tension. and there is a normal from the man. It is acting on the cage in the downward direction. So mass of the cage, so tension in the upward direction, normal in the downward direction, mc into g is in the acting downward direction, but acceleration in the upward direction. Now if you write equation t minus n plus minus mass of cage into g is equal to mass of cage into a, equation 2. Just add equation 1 and 2. We know the acceleration. We don't know two things. Tension is unknown, normal is unknown. So two equations and two unknowns. If you just solve these two expressions, we are going to get if we add 2t minus common factor mass of man plus mass of cage into g is equal to mass of man plus mass of cage into a. So 2t, t is equal to tension is equal to mass of man plus mass of cage into a plus mass of man plus mass of cage into g. This is the answer. And if you want to get the normal, substitute this tension value in equation 1 or equation 2. We will get the normal. Okay, this can be solved in a single step also. Shall we do in a single step? Okay, see, listen carefully. Okay, there is a division by divided by 2. So listen carefully. This is a man pulley. So diagram is not so good, but still okay. Now I am considering mass, cage and man as single system. Single system if I consider, then I am considering it as single block. Mass of cage plus mass of man. Now acceleration in which direction? It is in the upward direction. How many forces are there in the upward direction? The tension and the tension. Total force is 2t. How much force is acting in the downward direction? mc plus mm into g. Acceleration in the downward direction. Directly we'll get the tension 2t minus mc plus mm into g is equal to mc plus mm into a. We got the answer. T is equal to mc plus mm into a plus mc plus mm into g over 2. As usual, we got for the first expression. I think you understood this part. So let's we go to the one more question. It will be like this Newton's laws of motion problems becomes like a hand play if you understand. There are 4 pulleys and they are connected to a man. This man is in contact with the ground. Okay, there is a connection here also. The mass of man is mm. This is a stage, mass of stage. So the question is, they are moving upward with the constant acceleration a. Find the tension and mass of the tension and a normal reaction between the it's like there is a plank and man, as like we did for the previous case. For this problem, no need to do it like individual free body diagrams. Okay, I will do with individual free body diagrams also, but first we'll see directly. I am considering mass of man and mass of plank as a single system. If I consider like this, total mass of man, mass of plank. Now these are the single body. You understand? Whatever force is that's going up, should consider. This is one tension. How many tensions are there? 4. How much is the downward force? Capital mm plus mp into G. It's going upward with the acceleration A. So if you write equation 4t minus mm plus mp into G is equal to mm plus mp into A, tension becomes mm plus mp A plus mm plus mp G over 4. To get the normal, take any one of take man or plank as a system. Now separate it. Now I am taking man as single system. I will do with the two part. Taking man, so I am considering man. How many forces are there on the man? Upward, two forces, tension and tension. What else is other force? Contact force. Normal will be in the upward direction, remember. So two tensions, 2t, and there is a normal also, and what else? Downwards to mmg, the acceleration is in the upward direction. If we solve 2t plus n minus mmg is equal to mm into A, tension is already known. Substitute the tension equation 1 in the equation 2, you will get the answer. Okay, now let's see one more problem. So this is a block of mass m, and there is one fellow standing and catching it. Okay, and there is another case. This directly mass m without using any pulley. Okay, in these two cases, find the ratio of reaction from the ground. Ratios of reaction from ground. Reactions from the ground. So let's do this is a first and second. Now the man is moving. Is the man moving? No, the man is not moving, but the force is applied on it. But let's consider the mass of the man as mm. Mass of the man. Now let's solve this. Individual free body diagram. Both the bodies are moved with same acceleration upwards. T capital Mg A. T is equal to Ma plus Mg, or M into A plus G. Okay, now first case we are doing, remember, we are doing for the first case. Next, man free body diagram. Mass of man. Listen, see carefully. Man tension, how it is acting, the downwards or upwards? Upwards tension. Normal, it is in the upward direction, and mg in the downward direction. Let's draw this again. Tension T, normal M, mass of man into G. Acceleration is equal to 0 because the man is not moving at all. So the tension already we got. So tension T plus N is equal to mass of man into G, and the normal is equal to mass of man into G minus capital M into A plus G. Okay, this is one reaction from the ground, first case. Let's see the second case. The block also T, mass is mg, it's moving upward with A. T is equal to M into A plus G. And if you see the free body diagram of man, how the man is holding the rope, It's a very important. Man is the tension in the rope will act in the downward direction, normal in the upward direction, mg in the downward direction. Now let's see, draw the diagram. This is small m, mass of man, tension in which direction? Downward direction, and normal in the upward direction from the reaction, and mg is in the downward direction. Acceleration is equal to 0. Now the equation becomes n is equal to t plus mass of m into g, and n is equal to t is equal to m into a plus g plus mm into g. This is an reaction in the second case. Sorry, this is reaction in the first case. N1 over N2 is equal to mmg minus capital M into a plus g over m into a plus g plus mm into g, in which case the normal reaction is more. I leave